Alright, today we're working on section 8.5, which is solving rational equations. So whenever you have two fractions, rational expressions that are equal to each other, the easiest thing to do is to cross multiply. So I can have 3 times 4x plus 5 equals 9 times x plus 1. Then distribute, so that gives me 12x plus 15 is equal to 9x plus 9. And solve for x. So I'm going to subtract 9x, subtract 15. That gives me 3x is equal to negative 6, so x is negative 2. Sometimes you'll see word problems like this. It says an alloy is formed by mixing two or more metals. Sterling silver is an alloy composed of 92.5% silver and 7.5% copper by weight. You have 15 ounces of 800 grade silver, which is 80% silver and 20% copper by weight. How much pure silver should you mix with the 800 grade silver to make sterling silver? Okay, so we need to set this up, and we know that we have the percent of copper in a mixture is equal to the weight of the copper divided by the total weight. Because we're going to mix in pure silver. So we need to get our copper from 20% to 7.5%. So I need 7.5 over 100, because we're talking about percents, is equal to, and it's 20%, so 0.2. And I know I have 15 ounces, so times 15 is equal to my 15 ounces that I have plus however much silver I have to add to that. So then I can cross multiply, so that gives me 7.5 times 15 plus x is equal to 100 times 0.2 times 15. So 7.5 times 15 is 112.5 plus 7.5x is equal to 100 times 0.2 times 15, which is 300. Now I'm going to solve this for x. I'm going to subtract 112.5. So I have 7.5x equals 300 minus 112.5, which is 187.5. Divide that by 7.5. X equals 25. So I need to add 25 ounces of pure silver. Alright, I'm not going to do all of the problems on here. I have put the answers in case you want to work them and check them. So number 1, same idea. Cross multiply, so I have 3 times x minus 7 is equal to 10x. 3x minus 21 is equal to 10x. Subtract 3x, I get negative 21 is equal to 7x. Divide by 7, x is negative 3. Some are going to be a little bit more complicated, like number 3. Still going to cross multiply, so 11x plus 8 times 1 is just 11x plus 8. 2x plus 5 times x is 2x squared plus 5x. Now, anytime you have a quadratic, you want to get everything on the same side so that you can factor. So I'm going to subtract 11x and subtract 8. So that gives me 2x squared minus 6x minus 8. And the numbers that multiply to give me negative 8 and add to give me negative 6. Are, hold on. Actually, first thing I'm going to do is I'm going to divide all these by 2 because they're all even. So that gives me x squared minus 3x minus 4. Numbers that multiply to give me negative 4 and add to give me negative 3 are negative 4 and a positive 1. So x minus 4 times x plus 1 equals 0. So x can be 4 or negative 1. Solving these equations, alright? So sometimes you have two things that are added. Now, there's a couple ways you can do this. You can get these to have a common denominator first, or you can multiply it by every denominator, so, or by the least common denominator. So the least common denominator here, these don't have anything in common, is 4x. I'm going to multiply every term by 4x. So my x's cancel here and I get 20, plus my 4's cancel here, I get 7x, is equal to my x's cancel here. Negative 9 times 4 is a negative 36. I'm going to subtract 20, get 7x is equal to negative 56, divide by 7, x is negative 8. Okay, same thing on here. My denominators are x and an x minus 5. So multiplying everything by x and x minus 5. So out here, nothing cancels, so I'm going to get x squared minus 5x. Right here, my x minus 5x's cancel, or sorry, x minus 5, so I get negative 8 times x, which is negative 8x, equals, and over here my x's cancel, so I get 3x minus 15. So again, I want to get everything on one side, so I'm going to subtract 3x and add 15. So that gives me x squared negative 16x plus 15 equals 0. My numbers that multiply to give me 15 and add to give me negative 16 are negative 1 and negative 15. So I've got x minus 1 and x minus 15 equals 0. So x can be 1 or 15. Same thing down here. You'd multiply by 5x. You would multiply on this one by 2x times x plus 1. And on this one, x squared minus 1. That is a difference of squares. Remember on your difference of squares that if you have a squared minus b squared, that always factors to be a minus b, a plus b. So you can multiply by x squared minus 1, or you can multiply by x plus 1, x minus 1. And what that will do is it makes it just a little bit easier whenever you're going through. If you look at, okay, well this has an x plus 1, so if I write it as x plus 1, x minus 1, I can cancel out these. But that's the same as x squared minus 1. So if I write it that way, I can cancel these out, and x squared minus 1, that makes it a little bit easier to multiply right here. If you work this problem, you should get an answer of negative 2 and 5. Flipping over. Alright, so sometimes you're going to have stuff that looks just like what we were just working with. And anytime you have something like this, you're going to want to check your solution because you do have extraneous solutions with these. Remember, extraneous solutions are whenever you do all the work right, but you still have a solution that doesn't work. So I'm going to multiply right here. I've got x squared minus 9, which is x minus 3x plus 3. So I'm going to multiply all of those by one or the other of these. Because they're equal, I can choose either form. So I'm going to choose x minus 3x plus 3 on this so that I can cancel out. I'm going to choose x squared minus 9 on this one. So those cancel out, and x minus 3x plus 3 on this one. So my x plus 3's cancel, that whole thing cancels, and my x minus 3's cancel. I'm going to go ahead and distribute, so I'll get 6x plus 18 is equal to 8x squared minus 4x times x is 4x squared. Negative 4x times negative 3 is a positive 12x. I want to get everything on one side and combine like terms. So that gives me 4x squared, 0 is equal to 4x squared plus 6x minus 18. These are all divisible by 2, so I'm going to have 0 is equal to 2x squared plus 3x minus 9. Now, remember whenever you have a number right here, you've got to multiply it before you look at your x method. So 2 times negative 9 is negative 18. And we're looking for the numbers that multiply to give us negative 18 and add to give us 3. It's going to give me a positive 6 and a negative 3. You now have to go back, divide by that leading coefficient, reduce if possible. So negative 3 over 2 doesn't reduce. 6 over 2 becomes 3 over 1. And I'm going to have 0 is equal to x plus 3 and 2x minus 3. If I set my factors equal to 0 and solve for them, x is negative 3 and 2x is equal to 3, x is equal to 3 over 2. Check your answer. So if I plugged a negative 3 in right here, I would be dividing by 0. And you can't divide by 0, so this is extraneous. So my only real solution right here is this one. Number 7 and 8 both work very similarly. Again, you're going to check your solutions for extraneous solutions. And all you've got to do on that is look, whenever I plug it in, does it make one of my denominators 0? Consider the function f of x is equal to 2 over x plus 3. Determine whether the function inverse of f is a function, and then find the inverse. It is going to be a function. The inverse will be a function because if you graphed them, it would pass the horizontal line test. Remember, the horizontal line test says that if it doesn't have any y values that repeat, the inverse will be a function. Y values don't repeat. The inverse is a function. And to find the inverse, we're going to rewrite this as y is equal to 2 over x plus 3. Then I'm going to switch my x and y, so I get x is equal to 2 over y plus 3. And I'm going to multiply both sides by y plus 3. That gives me xy plus 3x is equal to 2. I'm going to move anything that doesn't have a y onto the other side, so I'm going to subtract 3x. So I get xy is equal to 2 minus 3x, and I want y by itself, so I divide by x. So my inverse right here is equal to 2 minus 3x over x. Alright, in section 8.2, example 5, you wrote the function 50m plus 1,000 divided by m, which represent the average cost of making m models using a 3D printer. How many models must be printed for the average cost per model to fall to 90? And we're going to solve this by an equation and using the inverse of a function. So with an equation, we would have 90 is equal to 50m plus 1,000 divided by m. Multiply by m, I get 90m is equal to 50m plus 1,000. Subtract 50m, I get 40m is equal to 1,000. Divide by 10 first, and so m is 25. So that is 25 models. Using the inverse, so we want to find the inverse of this. So solve this for c. So I'd have cm is equal to 50m plus 1,000. I'm going to subtract 50m. So that gives me cm minus 50m equals 1,000. These both have an m, so I'm going to factor that out, and I'll have c minus 50 is equal to 1,000. So divide by c minus 50. M is equal to 1,000 divided by c minus 50. And then you can plug in 90 right here. 90 minus 50 is 40. 1,000 divided by 40 is 25. This is helpful if you're going to work multiple problems with this approach. If you're doing a single one, you can just set it equal. But if you're going to look at several different values, it's easier to find your inverse. Go ahead and write your summary and then work on your online assignment of 8.5.